Morning, everyone. So, how's the conference going so far? Enjoying it? Yeah. Great job, Jonathan. Thank you. So, as Magnus said, my name's Dave Page. I work on Postgres, quite a lot really. On the core team, look after PGConf, do a lot of work in Postgres Europe and the Postgres Community Association in Canada. At Enterprise DB, I look after the majority of our tools, installers, packaging, pretty much everything apart from the database server, really. And I also have a team from time to time. So before we go and look at the some of the new features that are coming out in 9.4, I just want to give you a rough idea of how the process works, so you can understand some of the terms that I'll probably mention as we go through. So when somebody wants to develop a patch on Postgres, the first thing we really need to do is discuss the idea of the Postgres package mailing list. This is to ensure that no one else is already doing the same work. That's pretty important. You don't want to duplicate what somebody else is doing for fairly obvious reasons. You need to gain acceptance for the idea. Quite often people will come to a community and say, oh, I need a feature that allows you to select widgets. And the problem is, because if the Postgres community as a whole don't want that, there's probably no point in you writing the feature. Or you can just save a bit of time and do exactly how you want it yourself. Not only the idea, but you also need to get a consensus for the design and implementation plan. The last thing you want to do is spend 3 months writing code and then have Tom Lane say, no, that's not going to work, break in BCC or something. So it's really important that you spend the time to actually talk about the idea on the hackers list. Next thing you need to do once you've got the patch ready, post it to the mailing list, add it to commitfest.postgresql.org, which you'll probably hear me talking about a fair bit more. And then following that on the mailing list design, discuss and implement improvements as the discussion dictates until everyone's happy with the results. One thing to be aware of, you won't often get feedback during the main development cycle. You get them during these things called commitfests. Finally, once everything's looking good, breathe a sigh of relief, go do something else, have a beer, make some money. So commitfests, these are really important in the Postgres development cycle. They're periods of time where basically we stop doing development work and concentrate on reviewing patches, reviewing ideas that people have submitted on the commitfest application. We have 4 of them a year, June, September, November, and January. They usually last pretty much a month. They typically overrun slightly, but that's just the way it goes. The January one is normally much longer because that's the last one we have before we do the release. So, last thing before we get on with what's in 9.4, just some basic statistics as of a couple of days ago. We closed 4 commitfests, so we're basically now approaching the beta of 9.4. We've had 169 patches committed, 39 rejected, 24 that's still waiting for review, and probably are not going to get in at this stage. 15 that have been reviewed but are waiting for a committer to actually take them up, do the final polishing and commit them to the source tree. 11 patches returned to with feedback or waiting on the author. They may or may not get finished and actually put into the final release, which gives us a grand total of 341 patches in this release, which you can imagine is actually a hell of a lot of work. Some of those do appear in multiple commitfests. The bigger patches will sometimes be submitted 2 or 3 times until they're right. So, moving swiftly on, because I've got a lot of slides today. What's new in 9.4? How many Postgres developers do we have in the room? 1, 2. There's Stark's over there, but he really doesn't count. Oh, Bruce is down here. Alright, so if I'm making mistakes, bear in mind I'm not an expert in every single one of these features. Feel free to yell out and tell me I'm an idiot. You might want to just start now, it'll probably be easier. So this is a selection. I've spent the last 3 weeks or so trawling through the commitfest app, trawling through the mailing list archives. I've probably read 500 plus emails, trying to understand what all the features are, filter them down to what I think is a nice list to show you guys today. This is by no means exhaustive. There is a lot more that I'm going to talk about. I'm going to run through a lot of these quite quickly, because there are a lot of them. I'm going to stop and give some examples and show some additional information interesting ones. So we'll start with performance. On patch, use fallocate and PostgreSQL when creating new WAL files. So what this allows us to do when we create write-ahead log files, we basically have to create a 16-meg file and zero it out. This is a relatively simple patch. It just allows us to do that more quickly. Gives us performance enhancement, and it can actually lead to less fragmentation of the files. First really?
Yeah. Sorry.
Well, that's a good start.
But you gave permission, so.
Yeah. Oh, well, never mind.
Some systems are
Right, okay.
So
that's the problem. That's the problem you have when you have these huge, great big lists of features and hundreds of emails to trawl through and understand what's going on. You sometimes miss things. Oh well, I'm not my confidence with it. All right, next one. Next login to scaling. Did that stay in?
Yes.
Excellent. So this was some work by Heikki. You may know him. He's a Finnish guy. He's about 12 years old. 4 kids. And a sweater with a big elephant on it. This helps improve the scaling of the WAL insert operations by basically reducing lock contention. Simply put, it just allows for greater write scaling. Kind of related to that, we've got reduced WAL for update operations. By reducing the amount of actual WAL record, the size of the WAL records that need to be generated for update operations, we get less I/O, and again, more performance is the aim. Amit Pillar, Harry Babu were the primary authors on that one, and you can see Heikki was very well involved in it as well. PG pre-war. So this was written by a colleague of mine, actually, Robert Hart. This is linear contrib module. It gives you an SQL function that can use basically to pre-warm the caches. You can load the data either into the OS cache, so you can do that synchronously or asynchronously, or you can load it right away into the Postgres buffer cache. You can specify whether you want to load the heap or any of the other forks of the table. Postgres data is stored in these things called forks, which are files that contain both meta information and the actual data in the tables. So you can load whichever bits you want. So we use this as our first very simple example. You can see I'm starting the SQL session 9.4 there. I'm sure everyone uses PSQL before. No hands, or one hand. And you look unsure. Create extension of PG pre-warm. That's going to load the extension into the database, so it basically creates the function definitions for you within the system catalogs. And then the example here is just a very simple pre-warm PG bench accounts. That's going to fetch the whole of the PG bench accounts table straight into the Postgres buffers. Okay. Question?
How does that work if the table that you're loading is bigger than your memory?
Good question. I'm not entirely sure.
Okay.
Bruce? I'm assuming it's just going to move it into the oldest, the first thing it loaded in. Presumably in the same way that it would just in general operation.
Is there any basic analysis between PGConf and PGConf? Because I think PGConf, we use PGConf format. We don't.
I'm not particularly familiar with PGConf operation.
PGConf is a much more powerful version
Okay.
of it. But I don't think that one actually load it into the shared buffers, but they can do everything else more efficiently.
I don't know for that stuff.
No.
Lots of things, I don't know for that.
Oh, no, it doesn't. They fix that. It works in almost everything. It even works in Windows.
Wow.
All right, let's move on to something that hopefully I know a little bit more about, some sort of features. Extensible external toast tuple support. Who knows what toast is? Reasonable show of hands. So it's the oversized attribute storage technique. Is the official name for it. Basically, it's the way in Postgres that we take data that's too large to store within the actual tuple and store it off in sort of a separate table, effectively. The idea here is we've spoken for a long time about having the ability to use different types of compression with Toast. And this is just, it's a framework that allows us the ability to plug in different types of compression systems in the future. Again, a very, very simple one. There are no additional compression types that I know of yet, but it's ready to be used. You've heard about JSON in Postgres. I have to stop putting the hands up. So Postgres 9.4 has a new JSON-B data type. This is one of the big new features in this release. What this does is it actually stores JSON documents in binary format that doesn't need to be repassed when they're accessed. We have one of those primary authors or polishers sat right over there, so I'm sure he's going to correct me in a minute when I get something wrong.
Don't worry about it.
So the idea here is that it just allows for more, much faster querying and indexing, particularly through the use of the JSON-B hash index type.
Okay, I'm good with that.
Yeah.
I'm doing lightning talk on it later.
We'll go see Peter's lightning talk later on for it. So another community guy who some of you may know, Tom Brown, did some very, very quick benchmarks on this, literally the morning after it was committed. First column in the table there is JSON data in Postgres 9.3 using the existing JSON type. Second column is using the new JSON-B type. Third column is using MongoDB. You can see that the table size is slightly larger with JSON-B and much larger in Mongo, more I/O. The index size is much, much smaller for JSON-B, however. And the targeted index, where it's targeted on a specific single key within the document, is even smaller again. The real impressive thing, though, is the speed. So this was basically doing a count based on search for a particular nested value within the document. Whilst this is really just an extremely crude benchmark, it should not be taken as anything that's really publishable, you can see we're faster than Mongo, which is pretty impressive, and we're 18 times faster than we used to be. Thank you for that, Peter. A couple of little examples. I don't know how well you can actually see that from there. So here we can start off by just creating a JSON-B hashops index on a document column and a table. And one of the other nice features that was added to along with this patch was the containment operator. So now we've got that index, we can run very fast queries and do things like, does this document contain this other smaller document? Which is pretty cool and very fast. Alright, let's have a look at some system administration items. Most of you know that I'm the PGConf developer, because I mentioned at the beginning of the talk. One of the things we've argued about for 12 plus years now is how we can actually reconfigure the database server through SQL. In PGConf, we eventually gave up. We wrote a config module that allows us to write files into the data directory, and then we wrote code in PGConf that will read PostgreSQL.conf file back, allow the user to make changes in a nice GUI, and then save those back. We rewrite it, we reload the server. What we have finally now is AutoSystem. And what this allows you to do is to take any of the config parameters and say, AutoSystem set blah equal to blah. And what it actually does is it writes that to a file PostgreSQL.auto.conf, which is always read after the name Postgres.conf. So you should never manually edit the Postgres.auto.conf file. And what this means is when the server's reloaded, it reads the main configuration file and then overrides any values that it finds in there with ones that are also present in the .auto file. Got a quick example again. Show workman. So we can see we've got 8 megs of workman to start off with. And then just run AutoSystem set workman equals 16 megabytes. then run select PG reload conf. That's a stored function that just reloads the configuration from the configuration file, and then show workman again. We're going to go to 16 next. This is going to be awesome for future versions of PG admin. We're going to be able to rewrite the tools read into the configs, make it much more robust and usable.
Are you looking at adaptive workload, like shifting to the current workload as well with this sort of dynamic almost system type stuff, or?
Not yet, but it's an idea that has crossed my mind.
What if you just wanted to be active for that current?
If you just want it to be active for that session, you can just do so.
You want it to be database wide, but until you shut the database down and bring it back up, you want it to be the old stuff.
Yeah, you just need to on a session by session basis. This is going to rewrite the startup config, which is generally what most people need to do. Chris?
I mean, you could delete the auto comp file that can be started back and forth.
Yeah, but that also going to blow away
Everything
you've set.
else out there is not really designed.
And then you can see this is what the autoconf file looks like. Very, very simple. Heed the warning at the top, don't edit that file. So I think Stephen wrote this one, alter table space, move all to. It's a really handy additional SQL feature that allows you to move all the objects in a particular table space to another one. It's got some additional parameters you can set, so you can, if you're the super user, you can say owned by a particular user, so you can say all the table space, move all owned by Peter to some other table space that's running on really slow old disks that I don't care about anymore. And yeah, just annoying generally. So that's kind of a handy addition, I think.
Is the data online during the move?
I'm assuming it's going to take a full table lock on everything.
Well, it actually had a no wait when you didn't want to wait for the locks or.
What no wait does, it will exit with an error straight away if it can't get the lock immediately. So your session isn't sitting there waiting for the locks to be available.
Right, so
Or waiting for the locks to be free. Yeah, but I don't know how strong it is. I'm assuming it's a full. Yeah. Another nice new feature if you're using streamer replication, taking base backups at all. We now have the ability for you to actually relocate a particular table space to a new path when you do that base backup, which is a real time saver. So if you're moving to a different machine, it's got a different file system layout, you can just map the old table space location to the new one. While we're on the subject of base backups, you can now throttle them. So up until now, when you do a base backup, it's just going to take as much I/O as it needs, as it possibly can, basically. So what you can do now is you can specify this new max rate parameter. And you can specify a value anything between 32 kilobytes and 1 gigabyte per second, which is the maximum that it will try and transfer. One thing to note, this has no effect on stream WAV. It only has effect on the data directory that's being copied across, and any WAV that you actually fetch as part of the base backup as opposed to stream. Monitoring. This is obviously as a tools guy, this is one of the things I'm pretty interested in. PG Stack Archiver Statistics View. So one of the problems we have in some of the tools I look after is to actually monitor in depth what's happening in the replication system. You actually have to do things like count files on the file system to see what's been transferred, what hasn't been transferred, etc. This is a new system view that shows stats about the archiver, the number of WAV files archived, the name of the last file, the time of the last successful operation, as well as things like the errors. So you can very easily use, I imagine at some point in the future, if somebody's not done it already, there'll be a new version of check PostgreSQL, for example, which will make use of this or whatever you're using. Similarly, we're going to be making use of this in the Postgres Enterprise Manager tool that my team works on the EDB. It's going to be very useful for us to get rid of some potentially fragile code that we have already. We've also now got the planning time in Explain Analyze. If you ever wanted to see exactly how much time has been spent planning the query as opposed to actually executing the different nodes within the query, you can see this. Very, very simple addition, as a lot of these are, but potentially helps you track down queries that are difficult to plan. And similar to that, we now also show grouping columns in the aggregate and group nodes. Another simple but useful addition. This is another one I've got a quick example of here. So just doing a very simple explain, analyze, select some A balance from PGConf accounts, group by BID. And you can see up in the red there, we show that the group key is BID and the planning time is 0.0161 milliseconds. On a simple query like this, of course, the group key is probably not that interesting, but if you've got very complex queries, it can really help you actually understand what's going on in the query plans.
David, on the subject of monitoring, so you missed a bunch of things very important if you don't mind.
No, please go ahead.
PGConf statements, got a lot of attention in this release as well. One of the things, very simple thing, is we expose the
hash of the query.
Right, which seems trivial, but actually allows you to use, third-party systems can use that as a little identifier. But also, I wrote a patch that would have allowed PGConf statements to store arbitrarily sized query taxes. So that's part of how articles prefix already wrote it from there, which is also quite
Yeah, so Magnus did a similar talk to this a couple of months ago, and he was complaining to me afterwards that Heikki had said to him, "You've got things in the wrong order. You didn't include this feature I wrote." I did include that feature, but I had so many slides, it was one of the ones that didn't make the cut. Sorry, Peter.
that's all right.
Like I said, this is a big problem with this one. There are hundreds of commits, if not thousands, in the release cycle, and doing a 50-minute talk and covering everything is just completely impossible, unfortunately. So replication, I'm guessing there's probably a large percentage of people in the room that use replication in one form or another. So one cool feature that was added for this release, you can now set a new recovery target of immediate. So this is a value that you set in your recovery.conf file. So when you've got a standby server that's running in recovery mode, previously you could tell it to stop recovering and go into normal operation when you hit a named restore point or a timestamp or a transaction ID. What this allows you to do is to specify stop recovering, go into production mode online as soon as you get to a consistent state, which is always going to be quicker than any of the other quicker or as fast as any of the other options. So if you really need to bring that standby server up quickly, recovery target immediate allows you to do that and get it up and running as soon as possible. So there's something very wrong on the next slide. Time delayed standbys. Who's ever done a drop table when they didn't mean to? There's got to be somebody in this room. So the Postgres community guys have all done it, but none of the professional guys have.
And the only ones who did it.
Yeah. It can be used for a lot of other things, get you out of a lot of different straight. So the point of the time delayed standby is that you can have a standby server that basically can be constantly 6 hours, 12 hours, 24 hours behind your master. And it gives you a very simple way to get yourself out of trouble if you make any mistakes, your application does something stupid because somebody forgot to properly handle an error condition, or just one of any number of things that goes wrong. It gives you 6 hours or 12 hours or 24 hours to log into that server, PG on the table you dropped, and then reload it on the master, whatever you need to recover. it's just one of those handy things that if you've got spare resources, why not set it up? All right, so now I've flipped to it. Thankfully that slide looks okay. I get a little preview when we go up here and it was blank, which was very helpful. This is another one of the really big features. Simon and particularly Andrew Freund have been working towards a goal of eventually having what they call bidirectional replication in Postgres. One of the first steps in that is what we call logical decoding. This has a ton of possibilities. It's something I'm very excited about for all sorts of different problems that I know we've got where we can optimize some of our products, our customers can use it for doing all sorts of different things. The idea here is that the logical change set data can be extracted from the WAL files. If you know how Postgres works, the WAL files basically contain the page level changes to the block level changes for every block in the database as queries are executed. The problem with that is that it doesn't contain any actual information about what those bits mean. So you've got really no way of decoding it and using that information for anything other than applying to another server that's running on the same architecture and so on. What logical decoding does is actually allows you to get that information from the WAL files. So it adds a little bit more info in there and then allows you to decode it back on the fly as you need it. And you can consume this information either through SQL queries or using the streaming replication protocol. So that probably doesn't mean a lot to some of you. It's kind of hard to explain exactly what it does. We've got an example here. So what we're doing is we start off by creating a thing called a replication slot. This is kind of a named point to replicate from. These are persistent across server restarts. So if the server restarts, that slot will still be there, assuming you haven't explicitly destroyed it, and it will still keep collecting changes once the server's back up again. We can then do a select star from PG logical slot get change set, pass it the slot name. And at the moment, because the database is doing nothing, we don't get any rows back. So we'll do some work. We'll do a quick insert into the PG branches table. And then we do that select again. This time you can see that you've got the transaction starting, and then it tells us that table PG bench, table public.pg branches have an insert statement where the integer column BID was set to 999, the B balance integer column was set to 0, and the filler column was set to null, and the transaction was committed. And then when we finish, we just drop the replication slot, which stops it collecting the data. Now, a couple of examples of why this is useful. I'm sure there's people in the room who use Slowing. It has a bunch of triggers. We can add a table to a replication set. It creates triggers on it. And every time you do an insert or update or delete or whatever, those triggers fire within your transaction and store a record in a small table. Everyone knows trigger-based replication is slow. This gets around that. This replaces those triggers and it replaces that small table. So you can just replicate straight from here without having all those triggers involved. Nice and fast. It doesn't happen in line as part of your transaction, because we're creating the WAL anyway. So you basically just removed a whole chunk of slowing, the slowest bit. You could use this for something like auditing. If you need to audit changes to your data or log them to some, I don't know, to a text file or something, you can extract those changes from here. There's all sorts of possibilities to allow you to do really cool things with this. So I'm personally very, very thankful to Andrews and the other people who worked on this for getting it in there. Any questions before we move on? Yes?
What's the latency between when the transaction committed to get this information?
Well, it's coming out of the WAL, so the only thing it's really got to do is decode it. But I can honestly say I've never sat down and measured it. I expect it to be near instant. And I don't know of any reason why it wouldn't be.
Does it make the wall logs bigger or something like that?
Yeah, it does. You do need to have some additional information in the WoW logs, so it will increase the size slightly. There's a new WoW log level called logical, which gives you just enough to do this. And then the higher streaming rep levels that are already there also include that extra information.
Is the extension that compresses wall logs on the fly, retrieve circuits, would that not be working in the new format?
As part of the new, that will be unaffected. Okay, so some SQL features. Refresh materialized views concurrently. Incremental patch on Kevin Britner's original work to create new materialized views in the first place. This allows views to be refreshed without affecting concurrent reads. At the moment, I think it takes a full table lock whenever the system needs to refresh a view. This uses MVCC, which is full transactional semantics you would expect on a normal table. Allows you to carry on using that view whilst it's being refreshed, which is obviously very useful. We have a with check option for auto-updatable views. So if you've got a view that you've created over a table that says select star from a table where status equals 10, at the moment you can still insert into that view a value that has a status that is not 10. When you select back from the view, you won't see the value that you just inserted because it's filtered out by the labels of the view. What this does is allows you to actually put a check on the view to ensure that it will actually reject any attempt to insert data that wouldn't be visible in the same view. And this can be cascaded down across if you've got multiple views on top of it. The checks can be cascaded down through all of them. Just a nice way of ensuring that you can insert the data that you will actually be able to see again into that view. Of course, you can still insert the data into the underlying table as long as it's valid and meets all the requirements of the constraints. So this is really just enforcing the integrity of that view, making it so that you can't do anything unexpected. We've added unnest with ordinality. So basically this is a SQL standard syntax that adds a row number to the unnest function that's used to unnest an array of values into a record set. And you can use this with other set returning function calls as well. Very, very simple, and if you've ever tried to do this without ordinality, you'll know that it can be a real pain to do. But basically, it just gives you a row number. Tremendously useful for such a simple feature. Now, this is an interesting one. So I'm going to read this out and get a show of hands if you understood what I said when I finished. This patch introduces generic support for ordered set and hypothetical set aggregate functions, as well as implementations of the instances defined in SQL 2008. Percentile comp, percentile disk, blah, blah, blah. Also included a mode that's not in spec, as well as versions of percentile comp, percentile disk that can compute multiple percentile values in one pass over the data. Who understood that? Yeah, I read it about 8 times and still didn't fully understand it. So I'm going to try and give an example here, which I think I've got my head around it right now. So hopefully we'll get it right. So we'll create a table using generate series. So it's got 20 rows in it with values of 1 through 20. Select mode is going to find the most common value within that table. Now they're all unique at the moment, so it's just going to pick the first one that it comes to, effectively. It's undefined, so technically, so don't rely on it to always come back with 1 or anything like that. We insert another duplicate value, 15 in this case, when we run it again, you can see it's doing exactly what we said. It's looking over that set of values and returning the one with the highest rank, the one that's most common So let's have another. This is a more complex one. I'll hopefully show more usefully what this can be done, what you can do with this. So we create our table again. This time we're going to use the percentile disk function. So this is a discrete percentile. What it's going to do is select the first value whose position in the ordering equals or exceeds the specified fraction. So it's going to go on a scale of 0 to 1, 0.4 of the way through those values, and return either the value that's exactly at that position within the set, or it's going to return the next one. So in this case, with 20 rows, 0.4 of the way through actually is 8. Another example is continuous percentile. So what this is going to do is basically the same thing as a discrete percentile. But what it's going to, instead of moving to the next value, if it can't find anything that sits exactly in the position that you specify, it's going to actually interpolate a value between the preceding and the following value that is the exact position you've specified.
Shouldn't it return 9 if it does the one after?
The, what, for continuous percentile?
For discrete, you said it does the one after, but 8.6.
It does the one that's at, or the next one if it's higher than that. So if it actually calculated it to be 8.1, then it would return 9. But 0.4 happens to exactly come to row 8. It had been confused for a while, and I actually drew it out on the whiteboard, and it is correct.
Why did it return 8.6 and continuous? Same value.
Because when it's continuous, it's going to interpolate the value exactly.
It's between 1 or something, not 0.
Yeah, exactly. It's because it's between 1 and 20 and not 0 and 20, from 0 and 19. It is right. A colleague and I double-checked it about 8 times. I've got 10 minutes left. I think I'm good. Can any other hackers explain this one better than I can? Because it is kind of complex to get your head around.
Just to give a more general description, basically there are a number of aggregates that are sensitive to the order in which you feed the values into the aggregate. And effectively all of these examples are basically using the order by to control the order that the rows are fed into the aggregate.
Yeah.
These are specific examples, but again, without the ability to control the order, that, like sum and count, it doesn't matter what order they go in, right? In all of these aggregates, the order you put them in matters, and we're actually adding that capability.
That's a very good way of putting it, Bruce. Thank you. Any more questions to get me stumped on that?
So I think,
You're correct.
the answer is that percentile discrete takes the first, not the last.
Yeah.
That's that simple.
It takes the value that it lands on, if it lands on one exactly, or it takes the next one.
No, not the next, previous.
The trunk,
But
the truncates the.
Oh, no, you're right, sorry, yeah. Ordering equals or exceeds. See, now you've confused me, Greg, which is not important.
often one of the last things to get wrapped up in the release is documentation.
Yeah.
Bits like that might be clear.
Anyway, I encourage you to go and have a look at this, play with it, learn it, understand it, and then think about all the cool things you can do with it. All right, we're actually nearing the end now. I think I'm doing fairly well on time, to be honest. So we've got a couple of security things. First one was his fault. Anyone still using Kerberos 5 authentication? Good, because it's gone now. It's been deprecated for some time, since 8.3. That's how long we keep deprecating stuff around for. You should be using the GSS API instead if you're not already. So yeah, that's finally gone. We've also got various SSL and TSL that will hopefully add to the security of your systems. We added v1.1 and v1.2. TLS supports the server. Removed SSL v3 because it's sort of obsolete now. I think they even removed it from the server, right? It's still in libpq, so if you're connecting to an old server, it still works. Nobody seems to know. We also changed the default size of the suite to something that's a little bit more secure by default. And that was a guy called Mark McCrean who does a lot of work on the security and crypto code within Postgres. A couple of little miscellaneous things here, just to nearly finish us off. Dynamic shared memory. Woohoo! No? Unfortunately, it doesn't do what you would think it does. So everybody, I'm sure, was hoping this means you could change shared buffers on the fly without restarting the server, which is what I really want. But unfortunately, it doesn't. What it does do is allow the server to create new shared memory segments on the fly that can then be used to communicate between different processes. This is really a driver for future work that's being done on parallelism. You need shared memory segments to be able to communicate between work processes that we might create. So if you imagine we're actually executing a query, we might have a bunch of scan nodes within that query, so we might want to actually spawn off 3 work processes to go and do those scans for us. This allows us to create shared memory segments that the backend process will need to communicate with those workers, which hopefully we might start to see coming in the next release or so.
This is also going to continue on PostgreSQL memory allocation for the 9.3 or instead of 65?
Yeah, I think it does use PostgreSQL.
It'll use it on, but most platforms
Yeah.
most common.
Yeah. It was, I think Robert did the PostgreSQL work anyway, so he would have made it work on top of his previous work, I have no doubt. So the reason I'm showing you this is not because it's a useful feature for you today, but it shows you some of the direction we're working in. The fact that we do have these big projects that we're executing over a number of years and some of the really complex features. Kind of like the logical decoding one. The ultimate aim is to have bidirectional replication that can be very fine-grained, filter data and that sort of thing. But to get there, we've got to go in little steps. So we need logical decoding first, then we can figure out how to actually use that and implement code that can do the replication using it. Similar to the dynamic shared memory, you've also got dynamic background workers. So this is, again, related to parallelism primarily. The idea is that background worker processes can be installed as extensions in the server and then actually started using an SQL query. What then happens is that the backend that you're running on will signal the postmaster and say, start and keep watching and monitoring this backend, this new backend process. That backend process could be anything. It could be a task scheduler, or it could be a reader process. Pretty much anything that you might want to actually write and have running as a parallel process in the server. You can then kill those things, restart them, and so on. The postmaster will take care of all the details that it needs to make sure the system's running right. So that's pretty much it. Got one more thing. Has anyone ever seen this? I don't know how readable that is. So those are a bunch of log messages that say loaded library $/plugin debugger.so. If you've ever used the PGCQL debugger in pgadmin, you've probably seen these log messages a bunch of times. They're really annoying. I used to get a ton of emails about them. I've installed your debugger, why am I getting all these messages in my server logs? Basically, the answer is the log level on those particular messages was set at far higher than it was supposed to be. Take a bow, Peter. This single, most simple patch is going to reduce the quantity of emails in my inbox by about 50%. So basically, all this does is change the log level of that log message down to debug 1, I think it is. So you'll only see it if you're running with debug 1. Thank you. Thank you, thank you, thank you. And that's about it. Thank you also just to a few people without whom I would have found it impossible to understand half of this stuff, even to the limited amount that I actually do understand it, and to compile all the information. But the case of Michael Pack here, who, if you don't follow their blogs, you really should do. They keep an eye throughout the development process on new features as they're committed. They try them out, give you nice little examples so you can see how the things work and what toys and features you're going to get in the next release. Tom Brown, who spent some time obviously with the stats I showed you earlier, comparing Mongo to Postgres, he does a bunch of other things. He looks after the documentation to some extent, make sure every little typo is found, discovered and fixed, and so on. All the developers, obviously, without whom we wouldn't have Postgres. And one of the most important jobs that we need more of, if you want to contribute to Postgres, and you find yourself at a loose end, you're not sure what to do, come help us review some of these patches. Grab the source code, grab the patch, apply it. And even if you just send an email to say, I tried this, it compiled and it seems to work, that helps us. The more review you can do, of course, the better. But reviewers are really the one resource that Postgres lacks constantly. So the more people we can get reviewing, the better. And finally, thanks to the committers, I think, one or two in the room, for actually polishing and finishing up those patches and getting them committed.